A very good evening, sir. I'm Aarti Murugan, 6 BCAA. So, before I start off with cloud cryptography, I would like to just give a brief definition of what cloud computing is. So, cloud computing basically allows any organization to use its IT services or resources via the internet instead of you physically maintaining all the servers, which is much more harder and time consuming. And yeah, that's all I want to say about cloud computing. And the most popular cloud computing services at present are AWS, which is your Amazon web service. Then you have your Microsoft Azure and your Google Cloud. So now, why I chose cloud cryptography? So at present, cloud computing services are subject to cyber attacks and data breaches in the same way that the other IT assets are. And one of the way of improving cybersecurity for your cloud services is to use cloud cryptography, and that is the reason why I chose this topic. So I'll just move on to the next slide. Why cryptography in cloud computing is worth a shot. So I don't have to give much thought about this because by the end of this presentation, you will know why it is worth a shot. So, moving on, what is cloud cryptography and how does it work? So, let me first just start off with the definition of what cryptography is. So, the term crypto is derived from a Greek word which means hidden. So basically, cryptography is a study of secure communication mechanisms that restrict access to the information just to the sender and the receiver. There is no third party involved, and the information is intact just between the sender and the receiver. So now I just defined what cryptography is. So now, what is cryptography in cloud computing? Simple definition, that is encryption of data stored in a cloud service. So now, how your company can benefit from cloud cryptography. So there are two primary categories of cloud cryptography, one being data in transit and the other one is data at rest. So now, what is data in transit? It is just the data that is moving between the endpoints. It is basically when you use your internet browser, the HTTPS and the HTTP protocols, that is the one which secures all your information channel that you're using that you're using to visit different sites across the web. So we use this layer called secure socket layer, which is basically which which actually like secures your channel. So that's the layer of encryption that we're using, which is the SSL secure socket layer. Coming to the next one, it is data at rest. It is basically all that your sensitive data that that you're storing it in servers, servers, disks, and your cloud storage services. All of that is encrypted. And encrypting the data while it is being stored is only given no, the decryption credential to those employees with authorization. Otherwise, the person cannot access it, and the data is encrypted at all times. The next topic that I want to explain is symmetric cryptography algorithm. So this is basically a type of encryption algorithm which makes both data in transit and data at rest to be accessed by authorized users without any manual encryption or decryption. So now we have how to implement cryptography in cloud computing. We have three encryption algorithms, which is one symmetric key, asymmetric key, and hashing. So I'll be explaining symmetric key and asymmetric key. So, symmetric key algorithm. See, this particular algorithm uses one secret key for both encryption as well as decryption. So, for example, when you look at this picture, you have your plain text, which is being encrypted and which becomes a ciphertext. So, you're using one secret key for encrypting the message. And then on the other side, when he or she wants to decrypt the message, she uses the same secret key that was used for the encryption to decrypt the message and get the original text. So That's the most simple way of explaining what a symmetric key algorithm does. And it doesn't need any high computational power. And yeah, the main thing is that it's a two-way key. It's both for verification as well as approval. And these are some of the most popular symmetric key algorithms, which is DES, Data Encryption Standard. We have Blowfish, AES, which is your Advanced Encryption Standard, and you have a triple DES. So next we have our asymmetric algorithm. So as I mentioned earlier, in our symmetric algorithm, we use just one key to do both encryption as well as decryption. But then here we're using two different keys. One is called a public key, the other one is a private key. So the public key is used for encryption, and your private key is used for decryption. So, for example, you have your plain text, which is being encrypted using your public key and then becomes your ciphertext. And on the other side, when you have to decrypt the message, we use that private key or the secret key to decrypt and get the original message. And this is the most secure way to send any message. And these are some of the most popular asymmetric algorithms, which is RSA and ECC. Advantages. So coming to advantages of cryptography, cryptography in the cloud lessens the cybercrime cases. So meaning it keeps your information safe, and the information stays private just to the clients. So this basically lessens the cybercrime cases as it is being encrypted. And the next one will be the encryption keeps the information from being vulnerable. So when the information is being transferred from one PC to another PC, the encryption keeps it safe. When it's encrypted, the information is even more safer. So the next we have our disadvantages. So the cloud cryptography needs exceptionally advanced systems to maintain uh, encrypted. So yeah, as the framework should be, adequately versatile to update, which adds to the involved cost, and it needs these exceptionally advanced system to do all these encryption, decryption, all these private key, public key, all these. Obviously, we need a very advanced system to maintain all these stuffs. So the last one, I would like to show you the differences between a symmetric and asymmetric key algorithms. So symmetric key is a very old technique that we use to encrypt data, and we have our asymmetric key, which is our modern technique. We have and yeah, symmetric key is used to transmit big data. The other one is just for smaller, data. Yeah, as I mentioned earlier, symmetric key uses just one key, which is your just a single key for both encryption as well as decryption. And then you have your asymmetric key, which uses two different keys. One is your public key and your private key or your secret key. And then symmetric key is less secure as we're using just one key to, both to do both encryption as decryption. Asymmetric is more secure as we're using two different keys, which is your public key as well as your private key. Small ciphertext and asymmetric will produce a larger ciphertext. And thank you so much.